Factoring. So what's factoring? Again, when in doubt, let's go ahead and take a look at what Google has to tell us. So when I go ahead and I do a factoring search, I see that, all right, I'm getting some math related stuff. I see some numbers in there. And so, all right, let's take a look at their definition. But then all of a sudden in their definition, when it comes down to factoring, it's telling me that it's a financial transaction whenever some company's selling off their business. That doesn't sound like what we're going to be studying. So maybe I got to scroll up a little bit further. Oh, all right, here we come across factorization. And what I like in this definition now all of a sudden is this is actually telling me that, all right, in mathematics, factorization or factoring, all right, it looks like we're getting on the right pace here, consists of writing numbers or another mathematical object as a product. Product. All right, I remember hearing that word. That's right, product is the answer to multiplication. So I see that there's a theme in multiplication coming here. And what I see also, it says simpler or smaller objects or parts. And it says, for example, 3 times 5 is the factorization of 15. All right, that kind of makes sense. There's that multiplication, and 3 times 5 is factorization 15. But then it ends up with saying, and is a factorization of x squared minus 4. So is that telling me 15's a factorization of the polynomial x squared minus 4? Well, let's take a look at this a little bit further. So it's nice that we got started here with our little Google search, but factoring, it is connected with the word factorization. So let's just go back in time, if you would. If I think back to Algebra 1, I remember when we talked about prime factorization. So let's use their example. If I were to do prime factorization, what that would look like is as follows. I would have 15, and then I knew the prime numbers that multiply to give me 15 are 3 and 5. We used to do those prime factorization trees. Hence, 15 is equivalent to 3 times 5. Let's use another number. Let's just go ahead and try 40 then. I'll just change the color here. We'll go 40. So now, if I did the prime factorization of 40, this would be 2 and 20. But I got to remember, 20 is not prime. So that means the 20 can be broken down further into 2 times 10. And furthermore, 10 is not prime. So then this breaks down to 2 times 5. And there's our prime factorization, such that we just have these prime numbers, and we could write that as 2 cubed times 5 if we wish. So yes, factorization and factoring are going to require us to rewrite a number or expression as multiplication. It's going to actually be pretty powerful for us all throughout this Algebra 2 unit. Now, if we go a little bit further though, I kind of disagree with what was over there because they said something to the respect of x squared minus 4. Well, I got bad news for you. 3 times 5 is not the factorization of x squared minus 4. And what we're going to be doing is we're going to actually be learning how to factor these through our next unit. So if I look at x squared minus 4, I know that this factors into x plus 2, x minus 2. I'll teach you throughout other video presentations how to come up with that, but we could actually check this by quote-unquote foiling it or multiplying it back together, and we'd see those are equivalent. Furthermore, something you're going to be able to do by the end of this unit is take a quadratic of the form 2x squared minus 7x plus 6. And you're going to realize that I can actually rewrite this as 2x, x, and this would be minus 3, minus 2. Or in other words, this quadratic in standard form can be rewritten in its factored form as so. And they're both equivalent, meaning the exact same thing. And one of the things that we're going to be doing then is looking at the quadratic in this form to help us actually solve it in a more efficient manner.